This is Subramaniam Shankaran from IEEE. Now we are on the domain 1 of CISSP. Today we are going to discuss about the threat modeling techniques. So risk is equal to vulnerability multiplied by the threat multiplied by the probability multiplied by the impact. Okay. Now if any one of this is zero, then risk is obviously zero. So vulnerability is something that we have vulnerability stack, right? So it could be the vulnerability of the building, it could be a vulnerability with the hardware, with the power, okay, with the firmware, with the operating system, with the application, okay, with the network, with the user. Okay, so there are a lot of places where we have the vulnerabilities in the IT infrastructure. So we need to analyze everything. The NSS scan or Nexpose scan or ZAP scan, Nikto scan, okay. So GVM scan, all those things can, it can find the vulnerability on the application, web application, and then the infrastructure, network, etc. But the vulnerability, the firmware, and vulnerability with respect to the hardware, vulnerability with respect to the site, power, the supporting utilities, okay, all those things are something that needs to be calculated, using the processes. Okay, the vendor vulnerability, dependency on the vendor. Okay, in fact, we discussed about the availability, we discussed about the loss of a building, loss of IT infrastructure, loss of a supplier, loss of a personal, and loss of access to a building. Okay, these are the five things that we need to we need to plan for whenever it comes to the business continuity. Now, whenever it comes to the physical building, okay, so there are a lot of vulnerabilities in physical building also, the entries and exit points, etc. When it comes to the personal, okay, the weakest link of the complete security chain, okay, vulnerability of the supplier, okay, vulnerability with respect to the IT infrastructure and access to a building. Supposedly somebody is standing on the gate saying that I will not allow you inside. What else he will do? Okay, so in fact, until 2020, I was actually thinking that okay, the access to a building is going to be blocked only at the organization front. But then COVID, we had what is called a quarantine, and we had what is called as an I forgot that particular term. Okay, nobody was on lockdown. Okay, nobody was allowed to get outside. Okay, so access to a building could be stopped even at your residential front. Okay, that's what we came to know that. Now the cloud started booming. Okay, anyway, so coming on this particular one, so we know how to find the vulnerability. Now there are ways by which you can identify the threats. Yesterday in the video on FMEA, okay, we discussed about the attack frameworks. Okay, so MITRE attack framework and what are the different types of attacks it can actually do. But who can do an attack is actually a threat. There are close to around 19 different types of threat modeling technique, but what is required for CISSP is STRIDE and PASTA. STRIDE is a Microsoft way of finding the information. Okay, let me share the screen. Yeah. Good. CISSP made easy. Subbu teaches CISSP threat modeling techniques. Threat modeling is a structured process to identify, evaluate, and address the potential. Identification is the most important one. Okay, because if you miss out a particular threat, the others doesn't happen. The evaluation, addressing, and all doesn't happen, right? The most important step towards threat modeling is identifying identifying what the threats are. Okay, and threat identification. Primary goal is to understand what assets need a protection. Okay, there are valuable assets, there are threats. Okay, if the threat is actually going to look at the valuable asset, okay, that's when we're going to have a problem. If threat is actually looking at an honeypot, okay, we don't have a risk. Okay, threat multiplied by vulnerability multiplied by the impact is not there. Okay, if it is not an asset. Okay, if it is an asset but the probability is not there in the same formula, okay, the risk is equal to zero. So system representation, okay, documenting the system, including the architecture, components, data flows. STRIDE, we are going to look at the data flow anyway. Okay, so we need to know what is that we are trying to protect, okay, and how can people approach it. Okay, you have the very expensive jewelry at the center of the building, and how can people approach it? What are the doors? Okay, it's only one door. How can people come to that particular door? Which are the ways they can do it? Up, down, right, left, everything. Somebody can jump from the ceiling, or they can break through the basement and enter the room. We need to look at all the possibilities. Okay, doors and windows. Anyway, they're all the vulnerable layer. There could be vulnerability. Okay, on those layers also. So once you have an inside-out approach, okay, it'll give you an n number of possibilities of people of a thief or even an authorized person approaching this particular area. Let's not speak about the authorized person. Then we cannot think like a hacker. Okay, so like the thief can enter the premises. Similarly, Moment you're going to have the asset, okay, which is going to have very critical data in it, sensitive data in it, we need to know how can the people, okay, how can the hacker approach the system, okay, unauthorized way. So threat identification, uncovering the potential threats, vulnerabilities, attack vectors, etc. Threat analysis and prioritization. Okay. So if you personally ask me, okay, there are more number of threats within the organization than outside the organization. Okay, outside the organization, you have the public AP that is actually visible. Within the organization, all the systems are visible. Okay, you have zoning anyway, but what I mean to say is still because what usually what happens is whenever I train somebody on CSPT, certified security penetration tester training, the first system that they'll be touching their hands, okay, is their own internal system. Instead of me repeatedly telling them, okay, don't target your official company's asset, okay, they cannot stop that. Okay, it might become an insider attack for you. Elements of threat modeling, mitigation planning. Okay, you can either avoid the threat source. Okay, you can put in identification, authentication, authorization, encryption, hashing, blah blah blah, to ensure that there are layers of security before before the threat is going to approach. Okay, is going to approach the asset. Validation, iteration, continuously we need to do it. Okay, that means that I have done an NIST CSF implementation or ISO 27000 implementation. I know for all the authorized people who are not unauthorized people, etc. But I should be doing it repeatedly because the administrators could create an administrator equivalent account, okay, without a proper service request. There could be new joiners with extra privileges, etc. So continuously we need to do it. Okay, I would prefer doing it every month. I have done it every month called user verification testing when I was in Standard Chartered Bank back in 2002 to 2004. Okay, so I would request something like this happening. Okay, so not only identify your, the authorized user, but also ensure that the unauthorized users are kept at the bay. We have problem with the authorized user and unauthorized users both. Okay, we need to ensure that both of them are kept at the bay. Reduce the risk exposure. Okay, so authorized users anyway should access it, but it is unauthorized user. Try to avoid it. Reduces the risk exposure. Okay, inform the security decision. Informed security decision is what you're going to make. Okay, threat modeling techniques are going to identify the threats for you. What could be a threat? Man-made threat. Okay, or it could be a natural calamity. Natural calamities are something, pestle, political, economical, technological, legal, environmental, sociological. Okay, PESTLE, yeah, political, economical, sociological, technical, legal, okay, and then environmental or economical. If that is economics, this is environment. If that is environment, this is economical. Okay. So, we will identify the threats like this. Okay. The man-made attacks are anywhere there. Okay. Enhances the collaboration. So you need to sit with various departments to, arrive at the threat identification or threat modeling. Sit with them to do it. So it's going to pave way for better collaboration with all the teams who are internal. Okay, so threat modeling is very important for the organization, as equivalent as doing a vulnerability scan, as equivalent as doing a risk analysis or risk management cycle. Yeah. So threat modeling can be applied to software and application development. There are, in fact, the PASTA, okay, is very good. There's a lot of threat modeling techniques which are very specific to application development. And in the era of GDPR, PDPL, DPDP, okay, etc., okay, and CCPI, okay, you need to have a proper threat modeling technique to ensure that the privacy by design is implemented. Okay, so software application development, IT systems and network, IoT devices, business process, and the workflow. Threat modeling is not only technical, okay, it's also administrative, it's also physical. So when we say the security is threefold, technical, administrative, and then physical. Okay, so your threat modeling should also be threefold, technical, administrative, and then physical. Okay, anything that is administrative is process oriented. Okay. Why is very important? Supports what is called a security compliance. Okay, so you identify the threats and you have eliminated the threat source. You have put in a mitigation step to ensure that the impact is below the risk tolerance level. Sorry. Okay, so if they're going to ask a question, okay, have you done an privacy impact analysis, or have you done an privacy? How do you ensure that the privacy by design is implemented? We can say that, yeah, we have done threat modeling, okay, and so the entire system is designed with threat modeling outputs of threat modeling incorporated. Okay, it improves the system design. Okay, threat modeling process describe the system and the environment. Okay, so identify the assets Okay, so for example, for the PCI DSS, okay, the card data environment, card holder data. Okay, for the GDPR, UK GDPR, EU GDPR, excuse me, it's going to be, it's going to be the where the personal data is in transit, personal data is at rest, and personal data is in use. Okay, then identify the potential threats and vulnerabilities. Okay, we are going to have a look at the stride. Okay, to identify that and assess and prioritize the risks based on the likelihood and impact. Okay, so risk is equal to vulnerability multiplied by the impact multiplied by the probability multiplied by the threats. Okay, and then develop and implement mitigation for the highest priority threats initially. Review and update. Okay, so this is what we are going to actually see. The problem methodologies are stride, pasta, CVSS, tricky, attack trees. Attack trees, we have beautiful documentation from the cybersecurity group brochure on this. You can Google it and you will have this documentation. Simple but very effective. Vast security cards, hybrid threat modeling, quantitative threat modeling. Okay, stride is something which is very important for your CISSP examination. I will try to cover up the 19 different varieties of threat modeling as a separate video. Okay, getting deeper onto it. Okay, in fact, I want to give a video on FAIR. Okay, and that's what one of the requirements is. Okay, I'll try to do it. Okay, stride, spoofing. Okay, as a part of the man-in-the-middle impersonation attack. Tampering is modifying the data. Repudiation. Okay, the initiator of the transaction denying, saying that he has not done it. Okay, the information disclosure. The sensitive information is actually available for an unauthorized user. Denial of service. Okay, the system or the data is not available for the authorized user. Elevation of privileges. Okay, so the hacker can log on to the system as a normal user and elevate the privileges as a root or administrator. Okay, so this is on the stride. So first thing is defining the scope. Okay, so the scope of analysis. Usually it's like a card data environment, and where the personal data is in transit, personal data is in use, and personal data is at rest. Okay, or rather than the security, sensitive data is in use, sensitive data is at rest, and sensitive data is in transit. Okay, so that comes under the scope. Okay, gather the background information, system architecture, security architecture, assets, who are the users accessing it. Okay, what are the exact data and the business context for using the data. Clearly define what is in scope and what is outside scope. Create a data flow diagram. Okay, it might be from a web interface. Okay, the user enters the data, and from there on, where all it actually travels, and here's the final database and back to the user. This is actually called as a data flow diagram. So people draw a boundary called as a trust boundary and data flow diagram. For example, if the internet banking, anything that is publicly classified, you need not put in the user ID and password. But moment you want to look at your account details, you have to key in your user ID and password. And after that, okay, if you want to do a transaction, okay, then there's an OTP. So normally, if you want to view the publicly classified information, you don't have to put in your user ID and password. But if something that is confidential, your account detail, you have to put in your user ID and password. Okay, the trust boundary changes from the public to confidential. And if you want to transfer the funds from your account to another account, okay, then it becomes crucial or critical. Then the OTP hits your mobile phone and you have to enter it. It's going to be a Google authenticator, Zoho authenticator, blah, blah, blah. Okay, so data flow diagram is very important. Okay, you need to understand how the data is going to move between one system and another system. Okay, identify and categorize the threads using what is called as stride, spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Okay, spoofing is an impersonation attack, tampering is an integrity attack, repudiation is also an integrity attack. It's like source origin authentication. Information disclosure is a confidentiality attack, denial of service availability attack. Elevation of privilege is again an integrity problem, source origin authentication or authenticity of the transaction. Okay, so basically, we need to ensure that at every component, okay, be it your network, be it your server, be it your, whatever the component you're going to have from the web interface, okay, to the database, backend database, and back. Okay, you will do can the attacker spoof? Can the attacker modify something? Can attacker repudiate, saying that I have not done it after doing something? Can attacker look at the information? Can attacker ensure that the availability, the system is not available for the authorized user? Okay, so can the attacker gain an unauthorized access? Okay, and document the potential threats. Analyze and prioritize the threat based on the likelihood and impact. Okay, in fact, we want to have a separate video on FAIR. Okay, that's a request that I received yesterday on the risk management. Okay, so we are going to have a clear look on how you're going to categorize the loss events, okay, and everything. Okay, what is the point of action, okay, and threat capability, etc. Rank threats to focus on mitigation effort. Okay, for example, if the rank is high, okay, that needs to be addressed initially or the first. Develop and implement the mitigation strategy. Okay, you can implement technical control, administrative control, physical control. Okay, decide the risk responses, Atma, avoid, transfer, mitigate, and accept. Okay, is something that you can actually put in. Review, document, and iterate. Okay, so ensure that all the steps and findings, decisions are documented. Okay, and review the documentation very regularly, and threat modeling should also happen repeatedly and update the system as and when there are a significant update. Okay, so this on the straight. There's something called the PASTA process for attack simulation and threat analysis. I love PASTA. Okay, both the threat modeling as well as the actual PASTA. I had been delivering trainings in Italy. Okay, so I love having. I had been to a place called Anagni. Okay, Anagni or Anangina. Okay, I forgot actually. Okay, you had the countryside and wonderful pizzas and the pastas is what they actually serve you. And whatever they prepare, okay, the ingredients are picked up from their own garden. Okay, 7 stages of pasta. Business object, define the objectives. What are the business objectives? Okay, the clear direction, okay, for the pasta is the business objectives. Again, what are the requirements? Security and compliance requirements, GDPR, DPDP, PDPL, etc. Supporting the critical assets supporting the assets critical to the business operations. Okay. Now there could be assets that are very important, the development asset, test asset, DR assets, production assets. So you need to basically, identify the critical assets, okay, to support your business objectives and apply the pasta towards it. Operational impact consideration. Okay, if the system has gone down. Okay, so what's going to be the impact for the organization? Okay, define a technical scope. Card holder data. Okay, and card data environment. Okay, as with respect to the PCI DSS, and the personal data is in transit, personal data is addressed in use, and sensitive data is in transit in use addressed. That's going to be giving you the technical scope. Okay, as simple as that. Okay, so data type, the process infrastructure, documentation of the impact levels, application decomposition analysis, identifying the authorized users. Everybody else is unauthorized. Define the application entry points and trust level. Okay, the classic scenario I told you is the internet banking that we actually discussed. Documenting the data movement through the data flow diagrams. Okay, then you'll have a line. Okay, to also categorize or to identify yourself. The what all the is it a critical zone or the trusted zone or a public zone, whatever it is. Okay, trust boundaries and classifying all the data. Threat analysis, probabilistic attack scenario. Okay, so MITRE attack. Okay, is the is the best way we can get in all the attacks. Regression analysis, correlation of threat intelligence, various sources. SIM will actually do it for you, and documentation of threat patterns relevant to the particular data. Vulnerability and the weakness analysis, existing vulnerability reports. Okay, this is something that you can get from Nessus, Nexpose, etc. Application of threat trees, use and abuse cases. Use cases positive, abuse cases negative. Okay, so it's called the negativity testing or negative testing. Implementation of scoring system. Okay, CVSS, CW, CVE. Examination of the impacted system, subsystems of the data. Attack modeling and simulation. Attack surface analysis. Okay, so is it, for example, the attack surface, the web interface, who all can actually access? It's going to be open for the public. If not the public, then somebody has to establish a VPN connectivity. Then it's only the authorized users. Okay, and for the actual system in the data center, even the administrators can actually access it physically. Okay, so we need to understand the threat surface analysis for the impacted components, attack trees, attack vulnerability exploit analysis. Okay, so an impact assessment and the risk explanation is what you need to have as a part of this stage 6. We are going to have a separate video on the pasta. Securing system, I think, is one of the beautiful books that speaks about the pasta threat modeling. Okay. Risk and impact analysis, data and information summarization, the identification of risk mitigation strategy. Okay, what you have actually done. Okay, so you have identified the assets, you have identified the decomposition of the application is actually done. Analysis of the efficiency versus cost of implementation. If the asset that you are trying to secure is 50,000 US dollars and the cost of implementation is 75,000 US dollars, you can accept that risk. Okay. Development of the countermeasure. There's a difference between a countermeasure and a safeguard. Safeguard is going to protect. Countermeasure is going to attack it again. Okay, so what do the attack has happened? What else you will actually do the countermeasure? Safeguard will actually protect, secure the system. So this is all on your threat modeling presentation. This is Subramaniam Shankaran for CISSP training. Join us for the winning CISSP training, okay? And it's a 3 months program with the multiple sessions, multiple mock examinations, and hand-holding you until your certification. Write to me on training@ieee.org.uk or +91 99405 87544. Cheers, bye bye.